Hello students, how are you all? Hope you are enjoying this series of solving previous year questions. So now we are into the third part of system of particles and rotational motion. Now let's start this video. Question number 46. We did solve numericals up to 45, right? Now in part 2 we completed numericals up to 45. Now in part 3 let's start from 46th question. Okay. Now the question they are asking is, from a disk of radius R and mass M, a circular hole of diameter R whose rim passes through the center is cut. Super. Let me represent the diagram. From a disk of radius R and mass M. So let me represent that as a disk. Radius of this disk is going to be capital R. Mass of the disk is capital M. Okay. So a hole of diameter capital R. Diameter capital R. Look at this. A hole of diameter capital R is removed from this disk. Okay, super, sir. Why did you draw this red color circle as shown in the diagram in a sense? They said rim of this hole is passing through the center of the given disk. That is the reason I did represent it. It is like that. Okay, well, so total diameter of this disk which is being removed is R. Then what about radius? Radius is going to be R by 2. Hope you understood the representation. Next. So what is the question they are asking? What is the moment of inertia of the remaining part of the disk about a perpendicular axis passing through its center? Super. Now they are asking moment of inertia of this disk, removed part they are asking. This is how removed part. Axis is passing through center of mass and perpendicular to the plane. We know what is the meaning of axis is passing through center of mass and perpendicular to the plane. Let me represent initial moment of inertia of that body before removing this disk, that small hole. It is going to be mr square by 2 because it is a disk and axis is passing through center of mass and perpendicular to the plane. Okay, they are removing some mass. We don't know how much mass they are removing. As this is the disk, we have to consider area of the body. For example, for pi r square area, if mass is capital M, then for pi, what's the radius of the disk which is being removed? R by 2 whole square area. What is going to be the mass? There is a trick to find out this. So whenever there is a proportionality like this, you just remember, I'm giving numbers here. So 1, 2, 3, I need to find out 4. So the trick is 4 is equal to 1 divided by 2 into 3. This is how we have to represent. Let me represent. So small m is equal to, so what is mean by 1 here? It is pi r by 2 whole square divided by pi r square into total mass capital M. Pi will get cancelled out, r square will get cancelled, then small m is equal to m by 4. This is the mass which is being removed. Okay, now I have to find out moment of inertia of the body which is being removed. Let me represent that. Moment of inertia of the body which is being removed is this one. So radius is r by 2, mass of this object is m by 4. I need moment of inertia about this edge. So this is where I need. Okay, so this is where center of mass of the original object is there, and this is the center of mass of the original object through which we need to find out moment of inertia. Okay, so let me find out moment of inertia about this point. Then we have to use parallel axis theorem. Now whatever the points which I am representing in red color, those 2 points are out of the board. Let me represent the same diagram along horizontally. Try to understand, guys. This is how it is. Okay, so I need moment of inertia through this point. So we know moment of inertia through center of mass. What kind of theorem I have to apply? This type of questions are application of parallel axis theorem. So this is how it is. This is the axis. I need moment of inertia. So this is where we have to find out moment of inertia, and this is moment of inertia through center of mass. This is I2. So let me find out I2. I2 is equal to I center of mass plus ma square. So I center of mass is moment of inertia of that object through its center. Mass is m by 4, m r square by 2, right? R by 2 whole square divided by 2. This is m r square by 2. This is how we have to represent, plus mass of that object is m by 4 into a square is distance of separation between these two axes is r by 2, which is equal to r by 2 whole square. So what is the value we are going to get in this? So m by 4 into r square by 4, 4 4s are 16, 16 into 2, 32, we are going to get m r square by 32 plus m into r square by 16 we are going to get. So try to multiply it with 2, divide it with 2, we can equate the denominators. Then finally we are going to get 3mr square by 32. This is the moment of inertia of the removed object. Okay, now I need total moment of inertia. How to find out total moment of inertia? Total moment of inertia I is equal to moment of inertia of the original body minus moment of inertia of the removed portion, which is equal to I1 is mr square by 2, right? mr square by 2 minus I2 is 3mr square by 32. So let me equate the denominator. So multiply it with 16, divided with 16. So what we are going to get, 16 mr square by 32, 3 mr square by 32. That means we are going to get 13 mr square by 32. So this is the total moment of inertia of the object after removing the some portion of radius r by 2. They are asking moment of inertia through center of mass of the original body, right? Axis is passing through center of mass and perpendicular to the plane. That is the reason for the second body we are finding center of mass at the edge. This edge is the center of mass for the previous body. Is it clear, ma? Understood? Very good. Which option matches? Option D is the correct answer. Next, question number 47. Okay. So question number 47. Three identical spheres no, three identical shells, nothing but a spheres. Shells in the sense empty, hollow spheres, right? Look at the diagram. So that is how they have given in the question. Okay, so each of mass is small m and radius is smaller. Okay, mass is m and radius is r. They said it is a spherical shell, right? Spherical shell in the sense it's a hollow sphere. Remember, it's a hollow sphere. So what's the moment of inertia of hollow sphere? 2 by 3 mr square, right? Okay, so just remember that. Now consider an axis x dash which is touching the two shells and passing through the diameter of the third shell. Moment of inertia of the system consisting of these three spherical shells about x dash is super. Axis is passing through diameter of the one of the shell, but it is touching two cells. It is tangent to them. Then how to find out moment of inertia? Okay, let me name those spherical shells as 1, 2 and 3. So if you observe first shell, so axis is passing through its center of mass, right? This is how it is. Then what's the moment of inertia of first shell? It is going to be 2 by 3 mr square. 2 by 3 mr square. Okay, now observe second shell. If you observe second shell and third shell, axis is passing through the tangent. This is how it is passing. Now we have to apply parallel axis theorem. So how I can apply parallel axis theorem? Let me represent one more axis which is passing through center of mass. Here it is. This is axis passing through center of mass, and this is the axis through which I need to find out moment of inertia. Let's say this is I2. What's the radius is? It is m. R is the radius, m is mass of the object. Then I2 is equal to I center of mass plus m a square. I center of mass is 2 by 3 m r square plus m into distance of separation is r square. So what's the answer we are getting at? 5 by 3 m r square is the moment of inertia of the second shell. What about moment of inertia of the third shell? Moment of inertia of third shell is also going to be 5 by 3 m r square, because we are finding moment of inertia of the third shell through its tangent, right? It is going to be 5 by 3 m r square. Now what's the question they are asking? They are asking moment of inertia through that axis because of these three shells. Let me represent that. Then moment of inertia through x dash axis is equal to I1 plus I2 plus I3, which is equal to 2 by 3 m r square plus 5 by 3 m r square plus 5 by 3 m r square, which is equal to, denominator is same, you just add numerators. We are going to get 12 m r square by 4, which is equal to 3 m r square. This is the answer, Ix dash. This is the moment of inertia of the given system through axis x dash. Hope you understood. Which option matches? Option B is the correct answer. Next, super. So they have given question number 48, like moment of inertia of a uniform circular disc is maximum about an axis perpendicular to the disc and passing through point. Which point moment of inertia of the given disc is going to be maximum? Okay, let me represent that. Whatever the diagram they have given, I would like to represent along horizontal direction like this. This is how system is given. So just observe the side view. So this is where, this is how axis is passing through center of mass and perpendicular to the plane. Here it is. So axis passing through center of mass and perpendicular to the plane. Okay, so this point is A. So this point is A. So we have to consider another point. One point is given here which is very close to A. So here it is. This point is D. Okay, another point is B. Here it is. Let me represent that axis. I'm trying to represent with the different colors. Try to understand that. So point B, moment of inertia is, this is how it is. I'm representing axis like this. So this is how moment of inertia due to B. So moment of inertia due to D is going to be represented like this. This is how I need moment of inertia about this point. Okay, so this is moment of inertia through D. So moment of inertia through center is represented like this. This is moment of inertia through center. That is equal to IA. Okay, super. Now one more point is there, which is so somewhat far away from C, right? Sorry, far away from D. So even though it is at a different distance, let me represent that any position. You can represent at any position along the diameter, because it is a disc. You can rotate either C at position C, or you can place that position C here also. You are going to get the same moment of inertia. There is nothing wrong in that, because it is a disc, right? So you can take position either at this point. So I'm representing this like this. Try to understand this representation. Here it is. One more point through which we need to find out moment of inertia is C. C is represented here like this. Here it is. C. So this is the axis through which I need moment of inertia. Super. This is moment of inertia through C. Now one point that you need to understand is, what's the formula for moment of inertia of this disc? Moment of inertia of the disc is going to be I through center of mass through the point A is equal to m r square by 2. Moment of inertia through the axis IB, through the axis passing through tangent and parallel to the axis passing through center of mass is, this is going to be IA plus MA square, right? This is I center of mass, axis passing through center of mass. So IA is mr square by 2 plus m into r is, let's say it is r square. So finally we are going to get 3mr square by 2. Try to understand, moment of inertia through B is greater or moment of inertia through A is greater? Definitely moment of inertia through B is going to be greater, because this is equal to 0.5 times of mr square. What about this? This is 1.5 times of mr square. So moment of inertia is increased, right? One thing, if you understand, if distance of separation between the parallel axis increases, then moment of inertia is going to be definitely increases. Now you can compare. Moment of inertia at B is greater than moment of inertia at C, greater than moment of inertia at D is greater than moment of inertia of A. Try to understand here. A is the difference distance between perpendicular axis. If it is increases, moment of inertia increases. So A is perpendicular distance between axis. As A is increases, definitely moment of inertia increases. So this is where I am writing here. So A is the perpendicular distance between axis from center of mass. A of B is greater than A of C, greater than A of D, greater than A of A. This A is nothing but perpendicular distance. As A is greater for these points, then moment of inertia is also greater at respective points. Hope you understood, ma? Which option is correct? So option A is the correct answer. Next, let's move on to the next question, 49. So what is the question they're asking? The moment of inertia of a thin uniform rod of mass capital M and L about an axis passing through its midpoint and perpendicular to length is I naught. Super. Let me represent whatever the data they have given in the form of diagram. So let's say rod of mass capital M, capital M, small m, capital M. Length of this rod is L. Okay, super. So moment of inertia, we need about an axis passing through its midpoint. Okay, passing through its midpoint and perpendicular to its length. Okay, this is how axis is passing. So we know the moment of inertia of this axis, I is equal to ml square by 12, isn't it? Observe the diagram that I have represented. Whatever the three lines that they have given, I did represent it in the form of diagram, and it is equal to I naught, right? Okay, now what's the question they're asking? It's moment of inertia about an axis passing through one of its end and perpendicular to its length. That means they're asking moment of inertia about this point, right? Okay, so about this point I need moment of inertia. So what kind of theorem we can apply? Parallel axis theorem. So parallel axis theorem is I is equal to I center of mass plus m a square. Super. So these two axes are passing through one of the point and they are perpendicular to its length. That is the reason these two are in parallel. Hope you understood. So these two axes are perpendicular to length of the rod. So that is the reason I took it is as a parallel axis theorem. So I is equal to moment of inertia through center of mass is I naught plus moment of mass m. Distance between these two axes is L by 2. So it is going to be L square by 4. So which option matches? I naught plus ml square by 4. Option B is correct answer. Is it clear? Super. Next question number 50. It's very easy, guys. Understand the application of parallel axis and perpendicular axis theorem, then it is going to be very easy. Four identical thin rods, each of mass capital M and length L, form a square frame. Moment of inertia of this frame about an axis through the center of mass of the square and perpendicular to its plane. Super. Guys, observe this diagram. Whatever the thing they have given, I did represent it in the form of a diagram like this. Four identical rods, each of mass capital M. Okay, mass of each rod is M, length L. Mass M, length L. M, L. Super. Now what's they are asking? Moment of inertia of this frame about an axis through the center of the square. Okay, this is where center of the square, and this is how I need moment of inertia. Okay, super. Next, what's the question? This is how axis is passing through this axis, and through center of mass of the square and perpendicular to its plane. Hope you understood. This is the plane. This is complete plane. So this axis is perpendicular to this plane. Okay, so this is how I need moment of inertia. Let's say that is going to be I. Super. How to find out moment of inertia of this system? Let me give you a trick. Okay, so if you observe any one of the rod, it is connected like this. Okay, just I am showing this view. Hope you understood. Look at this. So this is rod. Length L, mass M. I need moment of inertia at somewhere else like this. Okay, so try to understand. If you observe, what is the distance of this rod from each rod? It is going to be L by 2, right? Distance of this rod from, distance of center of mass from each rod is going to be L by 2. Super. So this axis is at a distance of L by 2. I need moment of inertia through this point. Okay, na? Look at this. I did represent it in the diagram itself. So do we know moment of inertia, that is I at the center? Don't know. But we know moment of inertia of an individual rod which is passing through center of mass and perpendicular to its length. Let me represent that is as I1. Okay. Try to understand. Assume only this as an individual rod. Due to this individual rod, length is L, mass M, axis passing through center and perpendicular to its length. We know moment of inertia I1 is equal to ml square by 12, isn't it? Okay, but I need I. So how to find out I? I is equal to I1 plus m a square. These two axes are parallel with each other, right? And the distance of separation is L by 2. Then I1 is ml square by 12 plus distance of separation is L square by, not L square. See, ml by 2 whole square, isn't it? So this is 2. So from this what we are going to get? ml square by 12 plus ml square by 4. Multiply it with 4, divide it with 4. What's the thing? No, not with 4. Multiply it with 3, divided with 3. So what we are going to get? 4 ml square by 12. And final answer we are getting ml square by 3, isn't it? Okay, this is moment of inertia through center of mass due to only one rod. This is due to one rod, isn't it? How many rods, such rods are there? 4 such rods are there, and moment of inertia through center of mass is same as the first rod. So then what should we have to do? I total is equal to ml square by 3 into 4. So final answer is going to be 4 ml square by 3. Look at the answer. Which option is matching? Option D is correct. Very good. Understood? Very good. Question number 51. Go through each and every step. Then only it is very easy for you to understand. Okay. A thin rod of length L and mass capital M bent its midpoint into two halves so that angles between them is 90 degrees. Okay, super. So let me consider this is how original rod is, length L, mass capital M. Now this length is divided into two parts, two equal parts, because it is bent at the center and it is bent in the format of L, like they are perpendicular with each other. So length is L by 2, now mass is going to be M by 2, right? So length L by 2 and mass M by 2. Super. Now what's the question they're asking? They're asking moment of inertia of the bent rod about an axis passing through the midpoint and the perpendicular to plane defined by the two halves of the rod. Super. Let me represent the same diagram. So they're asking through this. This is the axis. This axis is out of the board. So if I represent here, it is very difficult for you to understand. Let me represent the diagram like this. Look at this. This is how we can understand the diagram, is how that system is rotating. They said axis is passing through midpoint. This is where it is midpoint. This midpoint I did represented like this. Okay, well? Axis is passing through midpoint and perpendicular to plane of that body. Okay, super. So this is the plane of that body. So it is perpendicular to it. Okay, so we know moment of inertia through edge of a rod. Let's say this is the rod and through its edge we know moment of inertia, and it is equal to m L square by 3, right? So let me find out moment of inertia I due to these two rods, due to let me write it is as 1 and 2. So due to first rod it is I1 and I2. So due to first rod it is going to be m by 2, mass is m by 2, L by 2 whole square divided by 3, ml square by 3, right? Next, m by 2, L by 2 whole square divided by 3. This is how we have to represent. So final answer is going to be m by 2 into L square by 4 will be there. 4 into 2, 8. 8 3s are 24, isn't it? So we are going to get m L square by 24 plus this is also m L square by 24. If you add these two values, we are going to get 2m L square by 24. 2 1s are 2 12s are, it is going to be m L square by 12 is the answer. Which option matches? Option D is the correct answer. Is it clear? That's all. This much easy it is once you understand how to apply. Okay, let's solve next question. Question number 52. Okay. Let me read out the question. The moment of inertia of a uniform circular disc of radius capital and mass m about an axis touching the disc at its diameter and normal to the disc is. Try to observe the diagram that how I am going to represent. They said axis is normal to this disc. Okay, and one more point they did mention. Understand that point. It is touching the diameter. Okay, well, let me say this is the diameter and this is how axis is passing through. It is touching the diameter. Through this axis I need moment of inertia. It's a disc, right? Okay, so moment of inertia through center of mass of a disc and perpendicular to its plane is I center of mass is equal to m r square by 2, right? Now we need moment of inertia through this point. Then moment of inertia I is equal to I center of mass plus what's the distance of separation between these two axes? It is going to be r. So m a square. Then I is equal to m r square by 2 plus m r square. Then I is equal to 3m r square by 2. So which option is correct? Option D is correct. Understood? Very good. Let me solve the next question. So they're asking the ratio of radius of gyration. Super. What's the formula for radius of gyration? First of all, let me represent that. Radius of gyration formula is root of I by m. I is moment of inertia of the body. Super. The ratio of radius of gyration of a circular disk about a tangential axis in the plane of the disk. Super. Try to observe in between the lines. Try to understand the question carefully. They have given tangential axis in the plane of the disk. This point is very crucial. Try to understand. This point will give you the correct answer. It is tangential axis in the plane of the body. Here it is. So let's say this is plane of the body and the axis is passing like this. Okay, na? Try to understand this. Let's say this is a disk and axis is tangent to the plane of the body. Here it is. It's a disk. This is how it is given. So this is actually moment of inertia of the disk which is passing through center of mass and along the diameter. Do we know moment of inertia of the object disk whose axis is passing through diameter? Do we know that? No, we don't know. Let me find out that. Then we can calculate what's the value of I. Look at this observation. It's an application of perpendicular axis theorem. I'll find out for both for disk and ring. So this is how ring and disks are represented. So let me represent three axes. So to apply perpendicular axis theorem, we need three axes, right? Yes, it is. Observe each and every axis, whether they are following the rule or not. X axis, and this is y axis, and this is z axis. Super. Moment of inertia through z axis, moment of inertia through x axis, and moment of inertia through y axis. This is how it is represented. Okay, I need moment of inertia through diameter, right? So what's the formula? Iz is equal to Ix plus Iy, right? So if you observe one more point, whether you rotate object about x-axis or about y-axis, moment of inertia of the object is going to be same, right? As moment of inertia of the object about x-axis and y-axis is the same, both the axes are passing through diameter only. That is the reason moment of inertia through their axis is going to be same. That's the reason I can represent Iz is equal to 2 times of Ix or 2 times of Iy. So Iz formula is moment of inertia through center of mass, right? It is going to be mr square by 2, as this is a disk. So it is a disk. So which is equal to 2 times of Ix, which is equal to 2 times of Iy. So then Ix is equal to Iy is equal to mr square by 4. So what is the meaning of this Ix, Iy? Moment of inertia of a disk whose axis is passing through diameter of the disk, passing through its diameter. Hope you understand. Let me represent moment of inertia of the ring. Now this is going to be ring. So what's the difference between ring and disk? If it is a ring, inside it is empty space. Disk, it is completely filled like this. Okay, na? So that's the only difference. Let me represent axis again. Observe carefully. So this is Iz axis, Iy axis, Ix axis, and this is going to be Iy axis. Again, these axes are perpendicular with each other, then only this law is applicable. So perpendicular axis theorem, parallel axis theorem. Ix, Iy, and this is Iz. I need moment of inertia through Ix or Iy. Ix and Iy axis are passing through diameter. So moment of inertia through respective axis is going to be same. So Iz is equal to Ix plus Iy. Iz is mr square, moment of inertia of the ring whose axis passing through center of mass and perpendicular to the plane. So 2 times of Ix, which is equal to 2 times of Iy. Mr square is equal to, from this mr square by 2 is equal to Ix, which is equal to Iy. So this means moment of inertia of a ring. So this is moment of inertia of a ring whose axis passing through center of mass and along diameter. So this is also axis is passing through center of mass. Remember this. And one more thing, these axes are on the plane of the body. Ix, Iy are the axes which are on the plane of the body. So plane of the body. This is the point we have to remember. Very good. Now what should I have to find out right now? Now come to the question. I need to find out moment of inertia through this axis. This is the axis. Moment of inertia through center of mass and along the diameter I know. So because of disk it is going to be mr square by 4. Due to ring it is going to be mr square by 2. Super. Let me find out radius of gyration of those two objects. So first of all, let me find out I is equal to axis which is passing through center of mass and along diameter plus ma square. So which is equal to, for a disk it is mr square by 4 plus m. A is nothing but distance between those two axes, which is equal to radius r square. So finally it is represented as 5 mr square by 4. This is for disk. Next, this is disk. For ring, so ring moment of inertia is equal to I through center of mass and passing and along diameter, right? And along diameter plus m a square, which is equal to m r square by 2 plus m r square. So let me add both of them. Due to ring is equal to 3 m r square by 2. So these are the moment of inertias. Then I need to find out radius of gyration. Then k disk divided by k ring is equal to, we know radius of gyration formula, that is root of I by m. And one more point, they said circular disc ring of same radius, same mass. Both the objects are having same mass and same radius. Let us see. So root of moment of inertia of the disc divided by its mass, root of moment of inertia of the ring divided by m. So this moment of inertia of disk ring is in the sense these values we have to substitute. Because of this axis only they are asking the answer. So this m will get cancelled. Then root of 5 mr square by, it is representation. So this is going to be 4, right? So 5 mr square by 4. 4 divided by root of 3 mr square by 2. mr square will get cancelled. Root 5 by 2 into root 2 by root 3 will be there, right? This 2 can be written in the form of root 2 into root 2, right? It is root 5 into root 2 divided by root 2 into root 2 into root 3. Can we write down like this? Yes, we can. So finally it is represented as root 5 divided by, so root of 2 into 3, it is going to be 6. So answer is going to be root 5 is to root 6. So which option matches? For question number 53, option C is correct. This much process is there. Don't decide immediately by seeing the question. Try to understand the question. So whatever I represented here, this is important. Tangential axis in the plane of the body, in the sense this is the meaning. Okay na? Next, question number 54. So try to pause the video and try to solve by your own. Okay, so The moment of inertia of a disk of mass capital M and radius r about an axis which is tangential to the circumference of the disk and parallel to its diameter. Super. This is also in the same format. Let me represent that. Assume this is a disk. Here it is. So let's say this is going to be diameter, axis passing through diameter and center of mass, and there is a one more axis which is tangent to circumference but parallel to the come on, this is how it is in the plane. So this is through center of mass and along the diameter, and this is the axis we need answer. They said which is tangential to the circumference, yes it is, and parallel to the diameter of the disk. This is the diameter of the disk. Okay na? So understood ma? So what is the distance between these two axes? It is going to be r. Let's say mass is capital M. How to find out I? I is equal to parallel axis theorem. I center of mass plus m a square. So what is I center of mass? It is axis passing through diameter of the disk. Passing through diameter of disk. So we know the formula for moment of inertia of the axis which is passing through diameter, that is equal to m r square by 4 plus m into a square is nothing but r square. So final answer we are going to get 5 by 4 m r square is the answer. Which option matches? Option A is the correct answer. Is it clear? Okay, next question number 55. Super. In this question, moment of inertia of a uniform circular disc about a diameter is I. Super. So moment of inertia of a uniform circular disc about its diameter is mr square by 4. This is the third time we are coming across this point. Okay, now what's the question they're asking? The moment of inertia about an axis perpendicular to its plane and passing through the point on its rim. Super. So the slight difference between the previous question and this question is now the axis is passing through one of the point, so like this, but it is perpendicular to plane of the body. This is how we have to represent it. Is it clear? Are you getting the difference? This is how it is. Very good. Through this axis I need moment of inertia. Observe the representation. So they said its moment of inertia about an axis perpendicular to its plane and passing through the point on its rim. This is the meaning of rim. Here it is. So what's the moment of inertia through its diameter? We know that is equal to mr square is equal to 4i, right? From this we can write down. Okay, now let me represent the axis which is passing through center of mass and perpendicular to the plane of the body. This is its axis, right? Now I need moment of inertia. Let's say this is I dash. That's what I have to find out, right? I dash is equal to I center of mass plus m a square. Distance of separation between these two axes is a. So I center of mass is m r square by 2. This is moment of inertia of the disk whose axis passing through center of mass and perpendicular to the plane. Very good. Plus m r square, which is equal to 3 times of mr square by 2 I dash. What is mr square? Mr square is 4i, right? So let me substitute that. 4i divided by 2. 2 2s are. Then I dash is equal to 6 times of I. This is the answer. Which option matches? Option C is the correct answer. Next concept is kinematics of rotational motion about a fixed axis. Super. Question number 56. A wheel has angular acceleration 3 radian per second square. That means alpha is equal to 3 radian per second square. Super. An initial angular speed 2 radian per second. Omega is equal to 2 radian per second. In a time of 2 seconds, it has rotated through an angle of, so t in t is equal to 2 seconds. What is the angle that it is rotated? No, they're asking a time of 2 seconds, it has rotated through an angle. Super. We have rotational kinematic equations. Let me use them. Theta is equal to omega initial into t plus 1 by 2 into alpha into t square. What's omega initial? It is 2 into 2 plus 1 by 2 into 3 into 4. Okay, na? So if you substitute all these values, what's the answer we are going to get? 2 will get cancelled. So it is going to be 4 plus 6. Answer is going to be 10 radians. This is the answer. Which option matches? Option A is the correct answer. To understand and how to apply this equation, we should know rotational kinematic equation. What are the rotational kinematic equations we have? Let me relate linear kinematic equations and rotational kinematic equation. Note. Okay, so linear kinematic equations, rotational kinematic equation, rotational kinematic equations. Linear kinematic equations, in the sense it will be in the form of initial velocity, final velocity and acceleration. Let me represent that. V is equal to u plus at, v square is equal to u square plus 2as. Next, s is equal to ut plus half at square. Sn is equal to u plus a by 2 into 2n minus 1. These are the equations we have. All these equations are applicable if acceleration is constant. Then only these equations are applicable. Remember this point. These equations are applicable only when acceleration is constant. Super. Let me write down rotational kinematic equation. Omega final. Linear velocity is replaced with angular velocity. Linear acceleration is replaced with angular acceleration. Very good. Let me find out that. So omega final is equal to omega initial plus alpha into t. Linear displacement is replaced with angular displacement. Omega final square is equal to omega initial square plus 2 alpha theta. Next, theta is equal to omega initial into t plus 1 by 2 into alpha t square. Theta n is equal to omega initial plus alpha by 2 into 2n minus 1. And one more point we have to remember is all these rotational kinematic equations are applicable only if angular acceleration of the given system is constant. Otherwise, these equations are not applicable. And I would like to give one more relation between linear and angular terms. Linear displacement is equal to r times of angular displacement. Linear velocity is equal to r times of angular velocity. And linear acceleration is equal to r times of angular acceleration. And this linear acceleration is tangential acceleration. Hope you know this representation. Very good. I would like to give some more formulas based on torque. The formula for torque in terms of moment of inertia is I into alpha. And one more formula, angular momentum which is L equal to I omega. This is applicable for rigid bodies. These formulas will really help you while we are solving numericals. And one more formula for torque in terms of linear force is F into R or R into F. So we can use that formula also while solving numericals. Just make note of these formulas. These formulas will help you really. Okay, super. Let me solve question number 57. A solid cylinder of mass 2 kg and radius 4 cm is rotating about its axis. What's the meaning of its axis? Axis is passing through center of mass and perpendicular to the plane, right? Question number 57. So what's the formula for moment of inertia of a solid cylinder about its axis? Moment of inertia of a solid cylinder about its axis is equal to mr square by 2. It is similar to disk, right? So they have already given mass of the object 2, radius is 4 centimeter, in the sense 4 into 10 power minus 2 meter divided by 2. 2 will get cancelled. We are going to get 16 into 10 power minus 4 kg meter square is the moment of inertia of the given object. Okay. Now initially it is rotating about 3 rpm. Okay, super. They have given omega in terms of rpm. We have to convert that into radian per second. 3 rpm. So what the meaning of rpm is revolution per minute. We know about this. We did learn in motion in a plane chapter. If you don't know about this, you just go through the motion in a plane chapter previous year questions. You can understand how can we convert revolutions per minute into radian per second. Actual unit of omega must be in terms of radian per second. So 1 revolution is equal to 2 pi radians divided by 1 minute is equal to 60 seconds. Then so 2 3s are 6, it will become pi by 10 is the angular velocity of the object. This is the initial angular velocity. Okay, next point, the torque required to stop it after 2 pi revolution. They're asking what is the torque to stop it in the sense final angular velocity is equal to 0, initial angular velocity is pi by 10. So after how much distance? Theta they have given, theta is equal to 2 pi revolution. Revolutions convert in terms of radians. This is 2 pi into 1 revolution is equal to 2 pi radians. So then theta is equal to 4 into pi square radians. Is it clear, ma? Now to find out torque, I should know moment of inertia and alpha. What's the formula for torque? Here it is. Torque is nothing but I alpha. Do I know alpha? Let me find out alpha from the given data. They have given initial angular velocity, final angular velocity and theta. From this given data we can find out alpha. So what's the formula which is applicable? So omega final square is equal to omega initial square plus 2 alpha theta. This is the rotational kinematic equation. Omega final square in the sense it is going to be 0. Omega initial square is nothing but pi square by 100. So alpha is going to be negative. That is the reason rotating object is going to come to rest position. So minus 2 alpha theta is 4 pi square. So finally it is going to be 8 pi square into alpha is equal to pi square by 100. Pi square will get cancelled out and alpha is equal to 1 by 800 radian per second. Now what's the thing we have to find out? We have to find out torque, right? So torque formula I into alpha. What's the moment of inertia of this object? 16 into 10 power minus 4. So it is 16 into 10 power minus 4 into alpha is 1 by 800. Super. So 8 ones are 8 twos are, then 2 into 10 power minus 6 Newton meter is the answer. Which option matches? Option B is the correct answer. Very good. Hope you understood. Next question number 58. Let's see how to solve this question. Three objects: A solid sphere, thin circular disc, and a ring. So A, B, C. First one is solid sphere. Solid sphere. Next one is circular disc. So disc, circular disc. Next ring. Super. So what is the question they're asking? Try to observe that. So each have the same mass and radius. Super. They all spin with the same angular speed omega about their own symmetric axis. Own symmetric axis in the sense moment of inertia of this sphere is going to be solid sphere 2 by 5 mr square. Moment of inertia of the disk is mr square by 2. Moment of inertia of the ring is mr square about its axis, its own symmetry axis they have given. Okay, what's the question they're asking? The amount of work required to bring them to rest would be. So generally, whatever the object which is having more moment of inertia, so that's the object, it is very difficult to stop it. Okay, if moment of inertia is more, then it is very difficult to stop that object. So work required to stop the objects is directly proportional to moment of inertia of those two objects, okay. So in this case, if you observe, moment of inertia of the ring is greater than moment of inertia of the disk is greater than moment of inertia of the solid sphere, then work required to stop the ring is greater than work required to stop disk, which is greater than work required to stop solid cylinder, which is here. So observe the option here. Work required to stop the object is directly proportional to moment of inertia. Which option matches? First option itself is matching. Super. Next question number 59. If you have any doubt how omega is directly proportional to, how W is directly proportional to I, in the sense we can use work energy theorem. So work done is equal to change in kinetic energy, right? So work done is equal to initial kinetic energy minus final kinetic energy, or final kinetic energy minus initial kinetic energy, we can write down here as final kinetic energy of the object is equal to 0, because we are trying to stop that object. So final angular velocity is going to be 0, so final kinetic energy is 0. So work done is nothing but kinetic energy of that object. So work done is equal to kinetic energy of a rotating body is equal to 1 by 2 I omega square. So already they said in the question itself that angular velocity of these objects is, all the three objects is going to be same. That is the reason W, work done, is directly proportional to moment of inertia. Hope you understood the representation. Is it clear now? Very good. Now look at the question number 59. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 centimeter. The question they are asking, what is the angular acceleration of the cylinder if the rope is pulled with a force of 30 newtons? Super. So this rope is pulled down with a force of 30 newtons. When this rope is pulled, this cylinder, it's a solid cylinder or a hollow cylinder? It's a hollow cylinder. This cylinder will rotate about this axis. This is how it is going to rotate. Okay, na? So what's the moment of inertia of the hollow cylinder? It is similar to ring. It is mr square, right? Okay. Now the question I need to find out is angular acceleration. Correct? Okay. So how can I find out angular acceleration? From the formula, torque is equal to I into alpha. So why should I have to use this formula? This is the first thing that we need to understand. Because there is a force and radius. Because of this force, this object is rotating. This force, 30 newtons force, is called as a rotational force. What's the formula for torque in the form of radius and force? It is going to be R into F, which is equal to moment of inertia is mr square into alpha. So R will get cancelled out. So force is 30 newtons, which is equal to mass is 3. R is 40 centimeter. It is 0.4 into alpha. So 3 tens are, then alpha is equal to 10 divided by 0.4. It can be written as 100 by 4, which is equal to 25 radian per second square. So that's the answer. So alpha is equal to 25 radian per second square. So which option matches? Option B is the correct answer. Check out the units carefully because option D is 25 meter per second square is given. Clear? Next, question number 60. A uniform circular disc of radius 50 centimeter at rest is free to turn about an axis which is perpendicular to its plane and passes through center. Okay, so they said a disc is there and it is free to rotate. Okay, so did they give any mass? No, they are given radius. What's the radius of this disc? Which is equal to 50 centimeter. Look at the diagram. So radius of the disc is 50 centimeter. This 50 centimeter you can represent in the form of meter, which is equal to 0.5 meter. Okay. Now what is the question they're asking? It is subjected to a torque which produces a constant acceleration of 2 radian per second square. That means a force is applied. It's a rotational force. Due to this rotational force, object is going to rotate, which produces a torque. They've already given a angular acceleration, constant angular acceleration, that is equal to tangential acceleration. Tangential acceleration is the acceleration produced because of this torque. Okay, so which is equal to 2 radian. No, this is angular acceleration, right? So angular acceleration in the sense alpha. Alpha is equal to 2 radian per second square. Let me convert this in the form of linear acceleration, that is at is equal to r alpha. R value is 0.5 into 2. So answer we are going to get in the form of 1 meter per second square. Super. Now this is not they're asking it's a net acceleration in meter per second square at the end of 2 seconds. Okay. Now this object is rotating like this. When this object starts rotating, its angular velocity increases. Omega initial is equal to 0. In object is initially at rest position. Let me find out omega final. Omega final is equal to omega initial plus alpha into t. Omega initial is 0, which is equal to 0 plus alpha value is 2 into, after what time they're asking? 2 seconds. So omega final is equal to 4 radian per second. Okay. Omega final, I got the answer for omega final. This is what I need. So I need to find out tangential acceleration. Tangential acceleration is going to be constant, that we know the value, that is at. So as this disk is rotating, we are going to get one more acceleration which is towards the center, that is centripetal acceleration. In the form of omega, it is omega square r. AC is equal to 4 square in the sense 16, R is 0.5, which is equal to 8 meter per second square. I need net acceleration. So A net is equal to root of AC square plus AT square. This is AC value. So finally we are going to get A net, I'm substituting here, A net is equal to root of 1 square plus 8 square and A net approximately we are going to get 8 meter per second square only. So this value we are going to get root of 65, which is approximately equal to again 8 meter per second square. So which option is matches? Option C is the correct answer. Hope you understood. Look at the diagram they have given in question number 61. Let me read it out. So point masses M1 and M2 are placed at the opposite ends of a rigid rod of length L and negligible mass. This rod, so whatever we have here, that length of that rod is L and it is massless. Okay, the rod is to be set to rotating about an axis perpendicular to it. Okay, the position of a point P on this rod through which the axis should pass, so that the work required to set the rod rotating with angular velocity omega naught is minimum. Very good. When you start rotating this masses on the rod with an angular velocity omega, what kind of energies they are having? So first of all we have to decide that they are going to have rotational kinetic energy, right? What's the formula for rotational kinetic energy? Omega is equal to, W is equal to 1 by 2 into I omega square. This is the kinetic energy these two objects are having, and that is the work required for us to rotate. Okay, so we should find out what is moment of inertia about point P. M1 is at a distance x, so M1 x square. M2 is at a distance L minus x whole square. At a distance L minus x, it is going to be mr square, right? That is the reason L minus x whole square. This is the moment of inertia. Okay, let me substitute that moment of inertia and work done formula. W is equal to 1 by 2 into m1 x square plus m2 into L minus x whole square into omega naught square. Okay, they said work required to set the rod rotating with angular velocity is minimum. They are saying that means, so for minimum or maximum we have to differentiate given equation with respect to two variable. What's the variable here? X is the variable, so we have to differentiate with respect to x and equate it to 0. So this is the condition for finding minimum or maximum. First of all, we have to differentiate the given equation with respect to variable and then equate it to 0. Let me differentiate this. So 1 by 2 omega naught square is going to be constant. So 2 m1x plus m2 into L minus x whole square is differentiated as 2 times of L minus x, and differentiation of the terminology which is inside is going to be minus 1. So equate it to 0. So send this terminology to right, it is going to be equal to 0. 2m1x plus 2m2 into L minus x. So this plus will become as a minus 2m2, so which is equal to 0. So this 2 will get cancelled out. Next m2x minus m1x minus m2l plus m2x, which is equal to 0. Now the thing I have to find out is x, right? So m1 plus m2 into x is equal to m2l. Then x is equal to m2l divided by m1 plus m2. So this is going to be the answer. Which option matches? m2l by m1 plus m2. Option B is the correct answer. Next, question number 62. In this question, an automobile moves on a road with a speed of 50 km per hour. Okay, so an automobile in the sense an object on the road. An automobile in the sense a motor vehicle which is moving with an initial speed of 54 kilometer per hour. First of all, try to convert this into meter per second. 54 kilometer per hour can be converted as meter per second as 5 by 18, which is equal to 18 ones are 18 threes are 15 meter per second. That's the speed of the automobile. Okay, next. The radius of its wheel is 0.45 meter and moment of inertia of the wheels about its axis is 3 kg meters square. Super. They gave radius of the wheels of this automobile. This is automobile. Radius of this wheels of this automobile is 0.45 meter and moment of inertia of those wheels, this is wheel. Okay, so moment of inertia they've already given 3 kg meter square. Okay, if the vehicle is brought to rest in 15 seconds, okay, brought to rest in the sense final angular velocity is equal to 0 in how many seconds? In t is equal to 15 seconds. What's the question they're asking? The magnitude of average torque estimated by its brake to the wheels. Super. I need to find out torque. What's the formula for torque? Torque formula is I into alpha. Do I know moment of inertia of those wheels? Yes, I know moment of inertia. Do I know alpha? I don't know alpha. Then I have to find out alpha first, then we can find out the torque. So initially they are given initial velocity, so that is equal to 15 meter per second. Try to convert that initial velocity into angular initial velocity, that is initial angular velocity is v by r. That's the formula. It is 15 divided by r is 0.45, nothing but 45 divided by 100. 15 threes are, which is equal to 100 by 3 radian per second is the initial angular velocity. So this is how you have to convert. This conversion is more important. Now I know initial angular velocity, final angular velocity and time. So from this given data, is it possible for me to find out alpha? Yes, it is. So omega final is equal to omega initial plus alpha into t. Omega final is 0. Omega initial is 100 by 3. As object is coming to rest position, it is a retardation. So minus alpha into t. T is 15 seconds. So from this 15 alpha is equal to 100 by 3. Then alpha is equal to 100 by 45. This is in radian per second square. So what is the thing I have to find out? I have to find out torque. Now torque formula is moment of inertia, I into alpha. So moment of inertia is 3. What about alpha? Alpha is 100 by 45. So 3 15s and 100 divided by 15 is equal approximately 6.666 something we are going to get. So make it as a 6.67 kg meter square per second square. So which option matches? Option C is the correct answer. Is it clear? Try to follow the steps that I have given carefully. Next, question number 63. A solid cylinder of mass 50 kg and radius 0.5 meter free to rotate about the horizontal axis. Okay, super. 63 solution. They gave solid cylinder. A massless string is wound round the cylinder with one end attached to it and the other end hanging freely. This is how we have to represent the diagram. It is rotating, it is free to rotate about its horizontal axis, right? So this is how it is. Okay, so one end is connected to the object, another end is left free. The tension in the string required to produce an angular acceleration of 2 revolutions per second square. Okay, the thing they are asking is how much tension is required to produce an angular acceleration. Tension required is nothing but I need to apply some force, right? Yes, it is. How much force I need to produce an angular acceleration of 2 revolution per second square. Alpha is equal to 2 into 1 revolution is equal to 2 pi radians by second square. So alpha is equal to 4 pi radian per second square. Okay, so this is the value of alpha. Let me find out force from this. So what's the formula for torque? Torque is equal to I into alpha, right? So F into R is the R into F is the formula for torque in terms of force. See, I need for force value. That is the reason I converted torque into force. Did they give radius? Yes, they did give the radius. Mass is equal to 50 kg. Radius is equal to 0.5 meter. Okay, so this is the data they have given. Radius, let me substitute that. Instead of substituting this, let me find out moment of inertia. Is this a solid cylinder or a hollow cylinder? It is a solid cylinder. So moment of inertia formula is going to be mr square by 2 to alpha. R will get cancelled. Then F is equal to m. Mass of that object is 50 into radius is 0.5 meter divided by 2 into alpha is 4 pi radian per second square. Okay, so let me, if you find out, if you try to cancel all these things, 0.5 is nothing but 1 by 2, right? It is going to be 50 by 4. 4 will get cancelled out. So you are going to get 50 into pi. So pi is 3.14. Pi into 50 is going to be approximately 150 plus value are going to be more than 150. So whatever the option which is matching is, so 157, approximate value is 157. So you might have confusion. Let me solve this. 50 into, what I'm doing is I'm writing this 0.5 as 1 by 2 divided by 2 into 4 pi. So this 2 will get cancelled. This 2 also will get cancelled. Now I'm going to get 50 into pi. Pi is 3.14. I'll make it approximately equal to 3. So 350 into 3 is going to be 150. But answer is not going to be 150 because I did approximated 3.14 to 3 only. So I have more than 3.4. So 3. So answer should be more than 150. So whatever the option which is matches and which is very close to 150 is, that is the answer. Understood? Very good. Next question number 64. Let me solve. Observe question number 64. Diagram type question. Okay, let's see, no problem. A rod PQ of mass capital M and length L is hinged to end P. That means this is a point which is fixed. That is the meaning of hinged. Okay, so this is a fixed position. Okay, next, what's the question they are given? So the rod is kept horizontally by a massless string tied to a point Q as shown in the figure. Okay, super. When the string is cut, the initial angular acceleration of the rod. Super. So if the string is cut here, what is going to be initial angular acceleration of this rod? Okay, if the string is cut, this rod tries to fall like this. This is how it is going to try to rotate with this fixed point. This is the fixed point with which this rod is going to fall down. Okay, I mean it is going to rotate because Point P is a fixed position, point Q is right now it is left free. So this rod is going to rotate with some angular velocity. That's the angular velocity we need to find out. To find out angular velocity, we should know some formulas. That is tau is equal to I into alpha. If you observe one point in all the questions, I am applying this formula. So whenever you come across questions based on this kind, as a dynamics of rotational motion, by the reading question itself we can understand the question is based on angular acceleration, angular velocity, then immediately use the formula I is equal tau is equal to I alpha and f is equal to tau is equal to r into f, moment of inertia of that object. So use such kind of formula, then it is very easy to get the answer. Okay, now this rod is rotating about a point which is at the end. So what's the moment of inertia of this rod which is rotating about its edge? It is going to be m L square by 3. We know the moment of inertia of this. Length of this rod is L and its mass is m. Okay, length already represented, mass is capital M. So it is m L square by 3. Okay, super. I know moment of inertia. I need to find out angular acceleration. First of all, find out torque. Torque is nothing but r into f, which is equal to I into alpha. So I should know where torque is present. So torque always present for this kind of bodies from its center of mass. This is how weight is acting, mg, and this is the length I should consider to find out torque. So force is downward, which is mg. Distance of that point, I mean center of mass location from end, the fixed axis position is L by 2. Then how to find out the torque? So length is L by 2 into force is mg, which is equal to moment of inertia is ml square by 3 into alpha. L will get cancelled out, m will get cancelled out, then alpha is equal to 3g by 2l. This is the answer. So which option matches? Option C is the correct answer. Is it clear, guys? Very good. Next, question number 65. In question number 65, they are given very simple. So the instantaneous angular position of a point on a rotating wheel is given by theta of t is equal to 2t cube minus 6t square. Okay, the torque on the wheel becomes 0 at super. So torque on the wheel becomes 0 in the sense torque formula. If torque becomes 0, then what about angular acceleration? Angular acceleration will become 0, right? Okay, super. From this, try to find out omega. So omega is nothing but d theta by dt. So which is equal to 6t square minus 12t. Now again differentiate this. Alpha is equal to d omega by dt. So which is equal to 12t minus 12, which is equal to 0. That's what they said. This is for if torque acting on the system is 0, alpha is equal to 0. If alpha is equal to 0, at that moment we need time. So 12t is equal to 12 and t is equal to 1 seconds. That's the answer. Which option is correct? For question number 65, option A is correct. Very good. So let's solve question number 66. In question number 66, they have given some diagram. I did represent that diagram over there. Let me read this question. Okay. A uniform rod AB of length L and mass M. Mass of this rod is M. Okay. Free to rotate about a point A. So the rod is released from the rest in the horizontal position. Super. So if it is released, it tries to rotate in this direction. Okay, so this is how it is going to rotate. Okay, given that the moment of inertia of the rod about a point A is ml square by 3. Super. So moment of inertia about this point is also given, that is ml square by 3. Amazing. The initial angular acceleration of the rod will be same. Question number 64 and question number 65 are similar. Okay, so weight of this body is going to act from its center of mass, right, which is going to be mg. Distance of the point which is fixed to center of mass is L by 2. Then torque is equal to I alpha. I need angular acceleration, right? So let's find that. So torque is nothing but R into F, which is equal to I into alpha. R is L by 2. So L by 2 into F. What's the value of F? F is mg. Because of this only object is rotating. So I is m L square by 3 into alpha. So m L will get cancelled. Alpha is equal to 3g by 2L is the answer. So look at the option. Which option is matching? 3g by 12. Question number 66, question number 64, similar. Next, question number 67. In this question, they give a wheel having moment of inertia 2 kg meter square. I is given 2 kg meter square. About its vertical axis, rotates at the rate of 60 rpm about this axis. Okay, initial angular velocity is also given, that is 60 rpm. Try to convert this in terms of radian per second. 1 rpm is equal to pi by 30 radian per second. Explained so many times, you just go through the previous session. 32 2s are 60. Then omega initial is going to be 2 pi radian per second. Okay, next, the torque which can stop the wheels of rotation in 1 minute would be. So what is final angular velocity? It is going to be 0. In how much time? So t is equal to 1 minute. 1 minute is nothing but 60 seconds, right? So to find out torque formula I into alpha, right? Do I know alpha? I don't know alpha. So how to find out alpha from the given data? So alpha can be written as omega final minus omega initial divided by time. Then alpha is equal to omega final is 0, omega initial is 2 pi. So minus 2 pi by t is 60 seconds. It is going to be minus pi by 30. Minus represent retardation. Okay, minus represent retardation. So let me substitute this. So tau is equal to I is the moment of inertia, which is equal to 2 into pi by 30. So tau is equal to pi by 15 Newton meter is the answer. Which option matches? Option C is the correct answer. Is it clear, guys? Super. Next, question number 68. In question number 68, they are given data like this. The moment of inertia of a body about a given axis is 1.2 kg meter square. Moment of inertia is 1.2 kg meter square. Okay. Initially, the body is at rest. That means initial angular velocity is equal to 0. In order to produce a rotational kinetic energy formula is 1 by 2 I omega square. Super. Which is equal to 1500 joule. Next, an angular acceleration of 25 radian per second square is needed. 25 radian per second square is needed. Must be applied about that axis for a duration of. To produce this much energy, I need to apply this much angular acceleration for a duration of. That's the question they're asking. Okay, super. First of all, try to find out final angular velocity at this energy. So that means this is omega final, right? So omega final square is equal to 1500 into 2 divided by moment of inertia, right? So omega final is equal to root of 1500 into 2 is 3000 divided by 1.2. 1.2 is 12 by 10. So it is going to be root of, so if you observe here, 12 ones are 12, 12 5s are 60, 12 2.5s are is going to be 32.5. This 2.5 into this 1000 is going to be 2500, which is equal to 50 radian per second. Very good. So this is omega final. I know omega final, omega initial, and alpha I have to find out time. So omega final is equal to omega initial plus alpha into t. Omega final is 50, initial is 0 plus alpha is 25 into t. Then t is equal to 2 seconds. Within 2 seconds, this is the energy that object is going to get. So which option is correct? Option B is the correct answer. Hope you understood, guys. So prepare very well, and I wish you all the very best. I will be there throughout your preparation and clearing NEET examination. Thank you so much.